The subject of this lesson is called Inputs and Outputs. This is a series of videos that I have created called Basic Training. These videos are to be used by students, my students, or any students around the world to help them get a better understanding of an electronic engineering technology program. In my opinion, I think there have been some gaps in the curriculum. A lot of assumptions has been made, and we have been graduating students without the confidence necessary to bring their uh, knowledge into their life with confidence and surety. And I believe one of those subjects is called Inputs and Outputs. In one of the videos, I introduced this concept of inputs and outputs when we were talking about filters. Here, in the electrical circuits analysis class, filters were introduced to the students, and the concept of inputs and outputs were introduced at that point. However, I think more experience needs to be developed in this area before moving to an official electronics class where they deal with more complex components such as transistors, diodes, and operational amplifier circuits. The concept of inputs and outputs must be firmly put into the student's mind so that they can confidently understand how to design circuits to solve problems of inputs and outputs. Let's begin. I will start with a very common circuit that we used in our electronics DC class. Now, the reason why inputs and outputs are so important in circuit analysis, because in the beginning, we just learned how to use electrical energy to operate basic devices. In the beginning, our main goal was to learn how to get the energy from a source to a load. And we learned that you can use a switch to connect the source to the load. You've learned that you can use a resistor to control the level of the voltage to the load. You can use a potentiometer to control the level of the load while the load is operating. And you can use a fuse to protect the load in the event there's a problem with connections. And the overall focus again was to get the energy from the source to a load device. But nowadays, electrical components take on more and more complex functions, such as LCD screens, computer monitors, stepper motors, servo motors, wireless transmission, sequential operation of various components. These are not, you're not going to be able to create that kind of complex just by simply using a switch. Something else must happen between the energy source and the final load in order to generate these complex functions. Because these functions are so complex, they must pass through several stages of operation. Basically, these voltages must be modified in some way. In our example, I'm going to show you the most basic operation of modifying a voltage level. Many times in electronics, you have a situation where you have a voltage that's just too big, and you want to reduce that voltage to another level. For example, you might have 12 volts, and you might need to reduce that voltage to 3 volts for some job. Now, there are many ways to get from 12 to 3. You can say 12 volts minus 9 volts, and that will give you 3 volts. Or you can say 12 volts divided by 4 volts. That will give you 3 volts. Well, actually, you can't divide volts by volts. I'll correct that and just say that 12 volts divided by 4 will give you the 3 volts. Or you can rewrite this as saying 12 volts multiply by 0.25 will also give you the 3 volts. As you can see, there are several operations to get from the 12 volts to the 3 volts that you need. We're going to use the very simple operation here, where we're going to use a component to subtract the voltage that we do not want in order for us to get to the 3 volts. You may have seen a circuit like this and before the idea was to get power from here to the load. Well, now our goal is to get from 12 volts to 3 volts. So we're basically talking about where we have an input voltage of 12 volts and we have an output voltage of 3 volts. This is where we begin the concept of input and output. When we start talking about input and output, we don't draw an energy source because we do not really care where the 12 volts come from. We only know that somewhere, if 12 volts becomes available on these 2 points, if 12 volts of energy exists between these 2 points, then somewhere over here between these 2 points, we want 3 volts. That's all we're really concerned about. And that is, once again, if you put 12 volts between these 2 points, then we want 3 volts to be here. So we're going to take those 2 points and bring them into some unknown box. We don't know what it is. And out of that box, we want to be able to measure the 3 volts. This is the concept of input and output. Our goal is, what can we do inside here that will allow 12 volts to become 3 volts? Well, one solution would be to go back to our original circuit analysis and understand that resistors in series separate voltages into parts from the source. Using that idea, we can use this simple circuit as a possible solution to this problem. If we redraw the circuit like this, where we are going to give it an energy source of 12 volts, and on one of those resistors we will take out the 3 volts that we want, then this forms the beginning of a design solution. If we put this inside of a box, then that becomes our solution, where if we put in 12 volts into this 2 points, then we will receive the 3 volts that we need to continue on with the next step. So the concept of input and output comes from a problem of how can we put in a particular value and get out the result that we want. Now this was a very basic problem. This is what we call a level shift problem. But there are so many other types of electronic problems that we may run across. This is when we start using mathematics to describe what we want to happen between one point to another point. As mentioned before, there are a variety of things that you can do to voltages. Basically, what you have is you have some type of input function, and that input would be, I guess you call it Vn, and then you would have some type of equation, and within that equation, or actually you have V out here, and within that equation you have Vn, and the operation within this equation would do the job of that particular node or that particular stage in the process. So I hope this helped you understand the idea behind inputs and outputs. Inputs and outputs are determined by the needs of the design.